section 7.1, angles and their measure. The first thing that we're going to see here is how to define a ray. A ray is a portion of the line that have a beginning and doesn't have an end. That's what we call a ray. So to define an angle, we have two rays that coincide in one point that we call vertex. This side of the ray is called initial side, and this side of the ray is called terminal side. This alpha is the opening. Here is measured how many degrees the angle measure, and is positive when you go counterclockwise rotation. In this case, the angle is beta, and this is the initial side, and this is the angle that we measure, initial side, terminal side. And this is clockwise rotation. So this angle beta is a negative angle, and this angle alpha is a positive angle. Finally, here we have a gamma vector, and this gamma vector is called coterminal because have the same initial side and the same head side as alpha has. So angle gamma is an angle that is coterminal with alpha and is in the positive angle because going counterclockwise rotation. So here we have a vector in standard position. Angle in standard position is when we have the initial side in the vertex is coincided with the origin, the initial side with the x, vertex x-axis, and the terminal side can be in whatever of the other two quadrants. When goes this side, so counterclockwise, we say that is a positive angle. Here we have a negative angle. This goes this way, initial side, and is also in standard position, but a negative angle. Here we can say that this angle theta lies in quadrant 2 because the terminal side is in quadrant 2. In this other side, we have this angle that is a negative, and we say that lies in quadrant 4 because the terminal side is in quadrant 4, as you can see here. Finally, here, when an angle coincides with one of the axes, we call that quadrantal angle. So every time that the terminal side coincides with one of the axes, we call that quadrantal angle. When we go one whole revolution, we say that this is 360 degrees, and this is a positive angle because go counterclockwise. Terminal side coincides with the initial side. Here we have 1/4 of the revolution, 90 degrees, and that's what we call a right angle. And here we have half revolution, it's a straight angle, and the measure of this is 180 degrees. So here we have 360 degrees, 90 degrees, and 180 degrees. Finally here, let's see some example how to draw this angle. 45 degrees, this is an angle that goes on the positive way, initial side, vertex, and terminal side, and this opening is 45 degrees. Negative 90 degrees, this is a negative angle, so go this way, initial side, terminal side, and this opening is 90 degrees. 225 degrees. Here is the vertex, initial side, terminal side, and this opening is 225 degrees because the angle is positive for this direction, counterclockwise. And finally, this one is also positive, go one whole revolution, which is 360, and a little bit more to get to 405. How you convert between decimals and degrees, minutes, seconds, measures for angles. Well, one revolution is 360 degrees. 1 degree represents 60 minutes. 1 minute represents 60 seconds. So to convert between degrees, minutes, and seconds, you need to transform this to a decimal in degrees. How we do that? Because we know that 1 minute is equal to 1/60 degrees, and 1 second is 1/60 times 1/60 minutes and seconds degree. So to transform this number to degrees, minutes, and second, we just copy the whole part. Here the degree is 40 degrees, and the 12 minutes we transform it to degrees divided by 60. And the 5 seconds we transform it to degrees divided by 60 and 60, which is 3,600. After we do that, we add all these parts and we get this now in degrees. Here we have another example. We follow exactly the same. Now we have this as degrees, and we're going to pass it to degrees, minutes, and seconds. So the decimal part of the 78, which is 562, we multiply it by 60 minutes. Then we get the whole part, 33. And the last part, 72, we multiply it by 60 again. And we get the second part. So we have degrees, minutes, and seconds. So we can pass from degrees to decimals and from decimals to degrees, minutes, second form. Here is another way to measure angles, that is the radians. And in the radians we use a circle, and this is the center of the circle. And we suppose that this side, which is the initial side, and this, which is the terminal side, have the same measure that this arc. When this happens, we say that this is 1 radian. So here we have 1 radian, means that this is 1, so we put 3 here, and this is 3, so this arc here is also 3, so that represents 1 radian. How we find the length of an arc circle? This is the formula that we follow. S, which is this part over here, the arc, is to S1, which is another arc, as theta is to theta 1. And here we can find a theorem that says how to find the arc length. You multiply the radius by the angle, and you have the length of the arc. So let's solve this problem. We have the arc of the circle, radius 4, and this is the central angle in radians. So we multiply this, and we know that the length of the arc is 2 millimeters. And finally, let's see how we convert from degrees to radians. We know that in 1 revolution we have 2 pi radians. So 180 degrees represent pi radians, and 1 degree is pi over 180 radians. In the same way, 1 radian is 180 over pi degrees. So if you're gonna pass from degrees to radians, what you have to do is multiply by pi over 180, and then simplify your numbers here, and you have your 30 degrees expressed as radians. In the same way, if you want to pass 120, you multiply that pi over 180, and then you just simplify and express this in lowest term. Here we have a negative angle. The only difference is that we have a negative in front, and here we have following the same procedure to compare another one from degrees to radians. When it's not exact, what you get is a decimal number. So converting from radians to degrees, now we have to do the order operation. We need to multiply by 180 over pi, and then we're going to cancel the pi. We cancel the pi, we divide 180 by 3, and we get 60 degrees. So we multiply by 180 over pi when we are passing from radians to degrees. And we get different examples.